Am I leggy, students? Am I leggy? Hello?
No, no, you're not.
No, okay. Uh, many questions come to me about the, oh, wait. Let me show you. Please open your Google Classroom, open the semester exam pointers. Open the semester exam pointers. Please tell me in the chat if I'm leggy, okay, students? Please tell me in the chat if I'm leggy. Do you understand? Okay, don't chat me. Chat in the group. Don't chat me personally. I will block if you chat me personally. Okay. Okay. So now we are discussing about many questions come to me about step by step. Yeah. Uh, let me go to okay. Speed time. I will repeat later. Yeah. And then formula about free fall. Free fall. Sectrizil, don't forget, don't worry. Sorry. Don't worry. I will send the copy to you later. Okay. Free fall. Okay. Free fall. If the object falls, right? When the object falls, it will reach terminal velocity, right? It was accelerated first, and then it accelerated with the constant acceleration. Yeah, g a equals to g, right? And then in this position, constant velocity, or we call it as a terminal velocity. In the condition of terminal velocity, sigma f upwards equals to the sigma f downwards. So the upwards forces equals to the downward forces. If we draw the downward forces, F downwards, F downwards equals to the F upwards. It equals to the force up. Okay. And then the important formula that you have to remember is about the final velocity before it reached the ground. Yeah. Velocity or speed before it reached the ground, before it reaches the ground. Yeah, it is v equals to g times gt, right? We have discussed this. And then we can also calculate using the formula. Yeah, you can also calculate using the formula v equals to 2gh square root of 2gh. Yeah, the velocity. Clear, students? Where the g, what is the value of g, students? The value of g, please answer me. 9.8 meter
9.8.
second square, or Newton per kilogram. Do you understand? Do you understand? Okay,
Yes.
that's about the free fall. And after this, about circular motion. Yeah, circular motion.
Sir, what is T?
Hmm?
What is T?
G, what?
T.
T.
Sir,
T.
what does
Oh,
the T in
okay.
T equals?
T. Okay. Do you mean this equation? When you ask something, because we are online, you have to state it clearly. T is time in the unit of seconds, and then G is gravitational acceleration. Don't say gravity, okay? So you have to say gravitational acceleration. Gravitational acceleration. And then H is the height of the object. The height of the object falling from the certain height, okay? Circle. Okay, now we goes to the circular motion. We move on to the circular motion. Let me draw the circle first. Okay, for the example, I have a planet here. And then and then we have moon. Yeah, and then we have moon. The questions is, why does the moon uh still rotate in its own path? That's the question. This is Earth. Yeah. This is moon. Okay. So uh the circular motion is affected by many forces, right? Affected by many forces. First, the circular motion affected by the gravitational attraction. Yeah, the F gravitational, let's say, we call it FG, gravitational pull from the planet. Yeah, okay. This is the FG. What is FG? Repeat after me. FG is gravitational. FG is what, students? Gravitational pull or force, or gravitational force from the planet, right? And then the moon also has the, what is that? The forward force. The moon also has the forward force. Let's say this is F forward. Let's say this is F forward, F. Yeah, F is what, guys? Forward. Answer me, yeah. I don't need deaf students, yeah. I will kick students who are not turning on the camera. Okay? Turn on the camera. Who's Kenzo Ezekiel? I don't have students Kenzo Ezekiel. Do I have students named Kenzo Ezekiel? Huh?
No.
Who's Kenzo Ezekiel? I will kick.
From business.
Okay. Turn on your camera, students. Turn on your camera. Okay. I don't want you sleeping. Okay. You have to stay awake and study with me. Yeah, because last time I checked the students sleeping during the online session. I don't want it. Forward motion. Forward motion is what students have. Okay. Nah, the moon is also affected by the centripetal force. Centripetal force. Okay. Also attracted by centripetal force. Now, what is it? Okay. What is centripetal force? Yeah, FC. It is centripetal force. Nah, students. Centripetal force is gravitational pull, right? Centripetal force Fc here, Fc equals to gravitational force. What is centripetal force? Centripetal force is the force, sorry, the force, sorry, I think it's error. My slides, cannot see my slide. Okay. Centripetal force, yeah, is the force, the force directed, yeah, toward the center of the circle. The center of the circle. Nah, I will erase this. So the gravitational pull is the, what is that? Centripetal force. Yeah. Okay. So now let's see, students. Let's see here. Now we can drag the line here. We can drag the line. And we can drag the line from here. And then we get the result, the resultant. Yeah, we get the resultant here, FR. Okay, FR. That's why the moon later will move here. The moon later will move here. That's why the moon later will move. Oh, the moon later will move here. Do you understand, students? And the cycle is repeated here in the new place. So the circular motion affected by forward motion and centripetal force. Yeah, thumbs up if you understand. Thumbs up if you understand, students. Huh? Thumbs up if you understand. The circular motion is the circular. What are the causes of circular motion? Circular motions, yeah, circular motion is caused by forward motion and forward force. Sorry, it's typo. Forward force, not forward motion. Forward force and affected by centripetal force. These two mark. If there is a question about circular motion, the key to answer this type of question is explaining about the forward forces and then explaining about the centripetal force, and both the forward force F and centripetal force from gravitational force, yeah, they will make the resultant that makes the moon rotate, move in circular motion. Do you understand, students? Thumbs up if you understand. Wuria, Tiffany, do you understand? Okay. So we have to discuss about forward force and centripetal force. The centripetal force pull to the center of the circle, and then the drag force pull to a certain direction, and then the movement is circular. Are you with me, students? Rebecca, clear? Rebecca, who loves her, clear? You lost him? Yes. Can you hear me, students? Can you hear me clearly? Thumbs up. Because my connection said unstable. Okay. Let's move on. Let's move on. What is the next pointers here? The next pointers is about resultant. Resultant, momentum, and density. Oh, right? Resultant. 3, about the resultant force. Yeah, force, turning effect, momentum, and density. Force, moment, momentum, impulse, and density. Okay, resultant. We talk about resultant first. Okay, so the first thing we talk about resultant is about aiding forces, right? Okay, directly give the example. How do you make the resultant? How do you make this resultant, students? If the case is like this. This is A, this is B, this is C. The resultant, the starting is at A. The final movement is C. So the resultant is A to C or C to A. What do you think? What do you think, students?
A to C.
A to C. Okay. The answer is A to C. Correct. So you drag this. Yeah. Yeah. From the start to the tip. Right? And then don't forget to give arrow. And then you label it with R. Yeah, R. Okay. There will be the type like this. Okay. And then spatial for right angle, you can implement trigonometry. For the example, yeah, for example, sorry. For the right angle, you can implement trigonometry. Yeah, for example, this is um 8, yeah, 8 newtons. And then going up is 6 newtons. 6 newtons. You can implement trigonometry or Pythagoras, right? Yeah, you can implement the formula from trigonometry or Pythagoras. This is the resultant. The resultant, if using Pythagoras, R equals to square root of 8 square plus 6 square. Correct, students? Nah, so the answer is 10, right? The resultant is 10 newtons, right? The example is like that. And if there is a force, students, if there is a force, graphic resultant, still resultant. If there is resultant, if there is object like this, for example, yeah, drag to the right, drag to the left. Yeah, drag again. Okay. Okay. Yeah, for example, this is 40 newtons and then 80 newtons and then 30 newtons, right? Because force is vector. Force is a vector, correct, students? Force is a vector. Remember this. This is really important. So the resultant Fr, yeah, or we can say sigma F equals to, yeah, going to the right is positive, right? Going to the right is positive. So we can say, using the Cartesian rules, going to the right is positive, going up positive, going down negative, going down negative, going to the left negative. But it is only when there is no weight. If there is weight, uh, let me show you. If there is weight, yeah, if, no, no, no. Yeah, if there is weight, there's weight, yeah. So going down, positive, going up, negative. Going down, weight is positive. And then going up, any force is negative. Do you understand? Thumbs up if you understand. This is only the exception. Okay. Force is a vector. Vector means has both, students. Vector has both
Magnitude and direction.
magnitude and direction. The other students, please answer. Yeah, if I'm asking, answer. Yeah, yeah. You are not a mute. What is that? So 80 plus 40 minus 30, right? So 120. So the answer is 90. Wait, let me check. Okay. Now, this is the resultant, right? And uh representing factors. Okay, graphical method. Graphical method. Yeah, graphical method means you must have a skill, yeah, to make a scale. Yeah, make a scale first. Okay. Example. Example. 100 Newton to the right, and then 40, sorry, 80 newtons to the 30-degree, yeah, to the direction of 30-degree. Now, if there is the case like this, you have to determine the scale first. So scale, what scale do you want to use? What is the scale do you want to use? Blah, blah, blah to blah, blah, blah. Please answer me. What scale do you want to use if the case like,
1 feet.
huh? Answer, other students.
1
Huh? 1
1
centimeter.
cm to 10.
1 centimeter to 10 Newton. Okay. Can 1 centimeter 10 Newton. Or you can state 1 to 10 like this. There are two ways to write. You can write 1 centimeter to 10 or 1 to 10 is okay. So now you draw. Waduh. Wait. Oh my God. So now you draw 100 Newton. 100 Newton, you will draw in centimeter. How much, students? You will draw in centimeter. How much? 10 centimeter. Am I correct? Am I correct, students? And then 80 newtons, you will draw in 8
8
centimeters.
centimeters.
You must use the ruler, students. 10 centimeter to the right. Okay. 10 centimeters to the right. Right. To the right. 10. You draw. Don't forget to give what, students? Arrow. Okay. Okay, students. This is 100 Newton. 10 centimeter. Okay. And then 30 degree. 30 degree to the 30 degree berat 8. Okay. Oh, not enough. I will move this first. 30 degree but 8. Loh. Why? Oh, I haven't clicked this. 8. Don't forget to give what, students? Don't forget to give what, students? Answer me. Type. If you don't want to say something, you are tired, type. I'm also tired. Come on. Huh? We have to draw what, students? In the end? Oh, Hennessy. Hennessy, you are living downstairs, right? Come here. Tip to tail. Okay. No. We have to draw the arrow. Okay. Now, Charlie is correct. We have to draw from the tip to tail. Yeah, from the start to the end. Okay. Okay, don't forget to draw the arrow. And then this one is the resultant. Yeah. Resultant. Resultant. How? Yeah, of course, we must use ruler. This is resultant, F resultant. This is how much? 80 Newton. How many centimeter? 8 centimeter. Of course, must use ruler. Yeah. If you don't bring ruler, you're done. Okay. 17. I think 17.5. Yeah, sorry. It should be until the end here. Yeah. Um, 17.5. FR is 17.5 centimeters. So the resultant is F resultant. FR is 17.5 times 10 newtons. It is 175 newtons. Yeah, 75 newtons. Do you understand? Now, the direction, because you haven't learned about the trigonometry, right? That you haven't in this type of question. Now, you can say to northeast. Yeah, you can say to the northeast. Northeast. Do you understand? Thumbs up if you understand. Answer me, okay? Okay. Oh yeah, maybe we skip first another type of questions. Maybe I will make. Let me later complete this first. Yeah, I will make the notes and share everything to you. This is from the pointers of MYE. Yeah, during the weekend, let me finish this and send it to you. All the summary. So you have like the pattern of the summary. Even though I have shared everything to you, I think more accessible if you can open like 1, 2, or 3 pages of the informations, because I shared you a lot of slides, right? Okay, maybe we can skip to another topic first. To another topic first. Wait. Because Sectrizil last time cut many times and haven't finished with the barometer. Wait. Sorry. Okay. Okay, Sectrizil, we have discussed about the pressure on solids, right? P equals to F per A. Now pressure on liquids. Yeah, liquids. Pressure on liquids, right? We call it as hydrostatic pressure. Hydrostatic pressure. Actually, I have discussed this in the class, but I know some of students still confused about this. Hydrostatic pressure, let me draw first. If we have a container, yeah, if we have container filled filled in by water, here, the water has density. Yeah, this is, for example, is water. And does the water has density, students? Yeah. Yes or no, students? Does the water have density or not? Thumbs up if the water has density. Okay. Okay, density of water, density of the fluid, F is fluid. Yeah. Rho F. Rho F it is density of fluid. It is 1000 kilogram per meter cube. Yeah, as you swim deeper, the you will experience more pressure from the water. From the example, the fish swim here. The fish swim here in the depth of the fish. Okay, the height of the water, for the example, is 10 meters. Yeah, this is a big tank. But the fish swim, yeah, this from the bottom, right? The fish swim from the bottom is maybe 4 meter from the bottom. Hydrostatic pressure is defined as density of fluid times gravitational acceleration times height. Oh, sorry, not height. Depth. Okay, depth. Height is usually height is denoted by H, but in this case, hydrostatic pressure, the H is depth. Yeah, depth. It is not the height. Okay. Now the question is, the depth is how much? The depth is the depth 4, students? What do you think? The depth is the depth 4, students?
No.
No, the depth is, according to this
6.
diagram, 6 meter. Remember that depth, the depth is measured from the surface of liquid. It's measured from the surface of the liquid. Okay? It's measured from the surface of the liquid. Clear or not, students? Clear? So, to calculate the hydrostatic pressure, pH, yeah, later, the unit of hydrostatic pressure just the same with another pressure. It is Newton per meter square or pascals, right? So density of fluid, yeah, rho F is what, students? Density of fluid, yeah, density of the fluid, okay, times G times the depth. So the density of the fluid is 1000 kilogram per meter cube times 9.8 meter per second square times the height. The height is 6 meter, right? 6 meter. And then you calculate, help me, I don't have calculator. How much, students? The unit will be kilogram, meter, 2 meter cancel, so kilogram per meter second square. It is Newton per meter square, or it is Pascal. Come on, how much, students? Answer me. Hmm? The answer is 58,800, right? Okay, 58,800. Yeah, just the same, 58,800. But is it to SF? Is it to SF, students? No. Yeah. The two SF is, the two significant figure is how much, students?
59,000.
59,000
Thousand.
Pascal, or in kilopascal, it becomes, in kilopascal, it becomes
59.
59 kilopascal.
Sir, can I screenshot this?
I will share everything to you in the Google Classroom. Okay, but not tonight.
Okay.
After this, I will go somewhere in the morning. Maybe after gym, I will send it to you. Okay. Physics is next week.
Okay.
Then next week again. The schedule of physics. What days? Yeah, I forget. Can someone see the schedule of physics? Because I'm using all my device, I can open the schedule.
Wait, for my class?
Yes. No. For Sec 3, all together.
Oh,
Huh?
like the class or
29th
the test?
November.
Pardon?
Are you asking for the class or the test?
The
Wait.
test. The test.
Oh, the test. Oh,
29th.
29th.
Huh?
Next Friday, like exactly 1 week from now.
1 week, 9, sorry,
29th.
29. So next week.
Yes.
Next week, Friday. Okay. So, for today and tomorrow, I will give again the extra lesson tomorrow at what is that? At 3. Yeah, at 3. For today and tomorrow, just strengthen the concept first. Okay, and then the next extra lesson is practicing. Plus, I will be making videos. Okay, continue. Okay. And then barometer. Okay, barometer. I think this is the one missed in the. Okay, and also some of the informations about, and I think energy resources I have discussed it to you, but I haven't talked about renewable and non-renewable energy, right? Even though you have learned in secondary too, but I think I need to what is that? Recall again those terms. Yeah, barometer. What is the function of barometer? Hmm?
Measure and
To measure
pressure.
the press to measure the
To measure
the air
the
pressure,
pressure.
or atmospheric pressure. Atmos sorry, atmospheric pressure. Yeah. Okay. What is inside barometer? What is inside barometer? Let me draw first. So basically, barometer is made of like petri dish, and then the test tube. We have the test tube here, right? And wait, why so ugly? Yeah? Wait. The test tube, and the test tube is filled by uh mercury. So this is what is inside, students? Mercury, and here it is vacuum. It means no air. The barometer experience the atmospheric pressure. Experience what, students? Atmospheric pressure. PATM, pressure of atmosphere. Now, atmospheric pressure is PATM. Now, how do inside this is mercury, right? Now, the common unit in barometer usually is 1 atmosphere. ATM is atmosphere, is 76 centimeter of mercury, right? And then 1 atmosphere equals to 760 millimeter of mercury. 1 atmosphere equals to 1 bar, right? 1 atmosphere is 1 times 10 power 5 Pascal, right? Now, this is the unit of pressure, okay, using in barometer. Clear, students? Now, how do you calculate the pressure of atmosphere? Now, the density, yeah, density of what? Mercury. Density of what? Mercury times the G times the height of mercury. Okay, the height of mercury. Do you understand, students? The height of mercury is until the vacuum. Yeah. Now the height is until this. Yeah, until the top. The mercury will make the convex what's that shape? Yeah. Mercury is not like this. Yeah, the surface of the mercury, it is a convex shape like this. Okay, this is the height. This is the height, right? The height of the mercury. Yeah, the height of mercury. Okay. Now, for the example, if the height of mercury here is 74 centimeter, right? 74 centimeter. Now, this formula is used to calculate in, what is that? Pascal later. The unit will be in Pascal. Let me search first. I forget the density of mercury. But usually density of mercury will be given in the question. Density of mercury will be given in the question. It is in kilogram meter cube. Wait, my internet is slow here. It is 13,000. That's it. 13,500. Now, density of mercury, it is not always like that, yes, students. It depends on the type of the mercury. This is 13,600 kilogram per meter cube. Yeah, it is 13,500 blah 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 something, and then we round off become 13,600. And okay, let's try to find the atmospheric pressure here. The density of mercury is 13,600, right? Kilogram per meter cube times 9.8 Newton per kilogram times the height is, nah, this 2 meter, how much, students? How many meter? 74 convert 74 centimeter to meter convert. Huh? 0.74. Correct. 0.74. Everything should be in meter. Yeah, this one should be in meter. Are you with me? Okay, meter, right? Now you cancel this, become meter square. Right? Okay, you cancel this. So the atmospheric pressure, the unit left is Newton per meter square or Pascal, right? Or Pascal. Now, let's calculate. Okay, 13,600 times 9.8 times 0.74, right? So 98.6 Newton per meter square or Pascal. Are you with me? Newton per meter square or Pascal. Clear, students? Now, if or in centimeter Hg or centimeter of mercury, the pressure, this is not atmospheric. Don't use PATM, yeah. P barometer. Sorry. PATM is atmospheric pressure is 1 atm, but this is, we are not measuring the 1 atm, right? We are not measuring 1 atm, so this is the pressure, the pressure the air right now. Okay, so the pressure of the air right now, it is, the height is height and then centimeter Hg. Now, so the answer, if in centimeter mercury, is 74 centimeter mercury. Okay, Clear or not, students? But it is rare. It is rare. No, it is not commonly used. Okay. Yeah. Any question? Special for this, I want you to take a note, students. Special for this, I want you to take a note. Yeah, special for this, only for this, please. Because this is really important. And you have to really write and understand. Wait. Is my calculation correct? 13,600 times 9.8 times 0.74. Okay. Okay. One more before I close. One more before I close. What if, okay, I copy the same thing from here. What if I duplicate? What if, is this not vacuum inside the, what is that? The barometer, it is air, or any gas, or whatever gas. So the formula will slightly change a little bit. The formula will slightly change a little bit. The formula, let me copy first, so I don't have to write a lot. If it is air, there is air inside it. The formula become yeah. So P80 P of the, yeah, plus the pressure of air. Now this air has the P air. Now usually given in the question. Now for the example, pressure in the air of the air is 0.2 Pascal. So you will get the answer 98.6. Yeah, plus pressure of air. Pressure of air here is 0.2. Yeah, the unit later will be Pascal. So the pressure is 98, sorry, 98.8. Yeah, Pascal. Okay, students. Now the difference is there is barometer with the vacuum condition, no gas inside it. there is a barometer with air inside it. Okay? Okay, students. Now I will compile the previous, let me finish all the formula for you and let me make the video later. Okay? Hey guys, thank you.